Thank you for everyone for joining us today. Welcome to our talk, Kotlin Multiplatform Mobile, from Hello World to the stars, or production, whichever comes first. My name is Pamela Hill, and I'm a developer advocate at JetBrains.
And I'm Tadeas Kriz, and I'm a senior mobile developer at TouchLab.
So our talk today is really about evolving our app from infancy to maturity when it comes to KMM, or Kotlin Multiplatform Mobile, where you're reaching for the stars, the coveted 5-star review, and the editor's choice badge. We'll be covering a few of the following topics. So we'll start out with a brief introduction where we talk about the chaotic oceans of the introduction, where we look about what is Kotlin Multiplatform Mobile. Maybe you've never heard of this concept before, maybe you have. What is Kotlin Multiplatform, and what's the benefits of using this technology? Then we'll crawl out onto the beaches and look at the greenfield and brownfield scenarios of new and existing projects. Suddenly, we'll take root and we'll look at the architectures, MVVM, MVI, MVP, MVC, and Tadeas' favorite, talk to him later about it, Viper. We'll also need to grow some scales to talk about testing. And then finally, we'll scale the mountains of debugging crashes on production. And then lastly, we'll reach the pinnacles of civilization when we ask you to ask us some questions. So let's start with the oceans of chaos in the introduction. So firstly, I'd like to talk about what is Kotlin Multiplatform as a technology in general. First, it's the SDK by JetBrains, yay. And it went into beta early in October. It allows development teams to share common code between Android and iOS, but it doesn't impose restrictions on non-shared code. That means that it doesn't dictate to you what you share and what you don't share, especially not what architectures you use or what design systems. So the multi-platform mobile compiles that shared module, the sharing that my shared module in the middle, into platform-specific artifacts that you add and use as a dependency in your app. For iOS, on the left-hand side, the Kotlin native compiler will compile it into .framework files or CocoaPods, which you then add and use as a dependency in your iOS app. On the left-hand side, the Kotlin JVM compiler will compile your shared module into a jar file or a .aar file, which you then add in and use in your Android app. Hello, everyone. We're glad that you're joining us. Thank you, everyone. Standing room only. Come on, that's great. Thank you. I mentioned that you can share code between platforms and that the choice is yours on whether what you share and what you don't share. But there are sort of common scenarios of use of code sharing. So in this slide, you can see that we're sharing the data or core layers and also the business and domain layers. But we decided not to share the presentation layers and also not the UI layers, the views. And that's fine, but we can go one step further and also share the presentation layers of presenters, view models, and controllers. To reiterate, the choice is yours. Of course, now we can also start going a little bit further and start sharing views as well, but that's a topic for one of Tadeas' sections. So what are the benefits of Kotlin Multiplatform Mobile? Firstly, it's about flexibility, the flexibility on what you choose, what you share and what you don't share. If you just want to share maybe a complex piece of business logic or an important algorithm and take things from there, you can take backseats. Secondly, the shared code lowers that effort and cost per feature. So, for example, you're not going to have to duplicate the effort in developing on both platforms and testing on both platforms, and that will drive down both your development and testing costs. But shared code is also about consistency, the consistency between platforms. So I've seen so many times, maybe you have too, that a team of Android and iOS developers work on a feature, and then they have a slightly different understanding of that feature, and it results in a sort of a nuanced implementation difference that's quite tricky to understand. So onto the beaches of use case scenarios. So first we have Kotlin Multiplatform can be used in a variety of ways. So from the new project scenario to the existing project scenario. So in this section, we're basically going to be talking about how to best share code between your platforms that works for your team. Perhaps your team is completely new and you want to create a completely new Kotlin multi-platform mobile project from scratch, the greenfield scenario. And if you use the wizard in Android Studio, the Kotlin multi-platform app template is going to create a project that looks a lot like this. So you'll have 3 modules, or well, 2 modules and a directory. The Android module, where the Android app lives. The iOS app is just a directory. It's got some Xcode stuff inside of it. And the shared module, which has a couple of source sets inside of it. And common main is where your common code lives, your shared code. And then we have some platform-specific integration code that lives in Android main and iOS main. So we like this structure a lot because it really helps you to make sure that your whole team is collaborating on that shared code, both iOS and Android engineers. And it's also much easier to debug from both Android and iOS's side. But something to keep in mind is that everything is stored in a single repository, including the iOS and Android apps, the so-called monorepo scenario. So if you've got a rough idea of what feature modules you'd like, you can also consider creating just a normal Kotlin multi-platform mobile project with feature modules that when you start out with your greenfield scenario. So here, for example, we have feature modules for analytics, validation, and formatting. So in this case, you make the iOS app a Gradle module that you will transitively depend on the feature modules, the analytics, validation, and formatting, and possibly export them. The reason for this is that you only want one, and this is an iOS concept, one XCF framework that each time you import something from KMM. And the reason why you want to only have one of those is because each time you're actually adding both the runtime, the Kotlin standard lib, and a whole bunch of other stuff to your iOS binary size, and that can actually escalate pretty quickly. Another reason is also that your XCF classes are sometimes incompatible across frameworks. But not all projects can be brand new, the brownfield scenario. So sometimes you have existing and separate projects for Android and iOS. In that case, you can easily create a shared module in your Android app that you use the new module template from Android Studio. It's just a little wizard. And that allows you to set up how you distribute it to Xcode. But this doesn't always scale so well. What if the shared module gets really, really big, really, really quickly? Okay, so instead you can actually create feature modules again. And in addition, you would also create this shared multi-platform mobile module with transitive dependencies on that feature module. Now, the reason for this, again, is that you only want one XCF framework. If you really want to reuse libraries across apps, you can go ahead and create KMM libraries. But you have to be careful in that you want to also make a Gradle module that imports those libraries because you only want one XCF framework. Otherwise, your iOS binary sizes are going to explode, and we wouldn't recommend that. Something I want to mention about is a new tool from TouchLab, where Tadeas is from. So if your iOS teammates are kind of hesitant about using multi-platform mobile, it provides you a way for your Android developers to write the shared code and then distribute it using either Swift Package Manager or CocoaPods to the iOS team without the iOS team ever having to touch Gradle or Kotlin. It's brand new and it's worth checking out. It would really work well for our brownfield setups that we just had a look at. So if you're considering creating a Kotlin multi-platform mobile project from scratch, or maybe adding it to your existing project, I'd like to make a few suggestions. Start small, firstly. There's enough to figure out just by adding a simple shared module with just one function in. And the reason for that is that, firstly, you have to check that everything is still running locally. Is it still working with your CI/CD pipeline? And is it causing major issues in production? It shouldn't, but you still need to check. And that will also give you the buy-in that you need and give your whole team a sense of comfort with the technology so that you'll start adding more and more to that shared module. And it will also alleviate some anxiety in your team. But secondly, you also want to keep your API really, really simple. Your iOS team will thank you later. You will thank you later. There are currently some limitations between Kotlin and Objective-C where making things like sealed classes or default arguments or enums, they just don't work. So don't try to get too fancy too fast. And thirdly, think like a library developer. I would want to sort of reference Joshua Bloch's How to Design a Good API and Why It Matters presentation. Really have a look at that one. But for now, just implementation shouldn't be impacting your API. So in other words, I shouldn't be able to guess what API you're using or what libraries you're using to implement your API. Minimize the accessibility of everything. So liberally use the keyword internal, which will keep most, but your public API sort of closed in your module. And that's also going to do wonders for your iOS app binary size. And then coexist peacefully with both platforms. So, for example, don't make your iOS developers write gross Objective-C or Swift code. Work with them so you understand what good iOS code looks like, and also then write APIs that will allow them to create great-looking code. Something to note here is that both JetBrains and TouchLab are working on something for the Kotlin Swift interop, but it's still in the works.
Now we look at the application architecture for KMM. Before I begin, I want to ask, is anyone here Snake lover? Viper users? No? No one? Okay. Cool. That kind of caught me by surprise. So first I want to mention that there are no silver bullets, so whatever I'm going to talk about won't work for everything. We already know that from Hadi. And with the more complex your app is, even with KMM, the more complex your architecture will be. And so whenever we're talking about MVVM, MVP, all of those M architectures, they usually are only part of something larger. And we really want to talk about a multi-layered architecture where we have three main layers. Again, the more complex the app, the more layers you will have. But basically, the presentation layer is where we think about the MVVM, MVP, and so on. The reason why I'm saying that is that oftentimes you see tutorials where modal in the MVVM or something is very simple, kind of like just Pojo classes, and you then see everything in one layer, and it stops working really quick. And also, when talking about KMM, sometimes okay, I don't want to share the presentation layer. I want that to be native to iOS and Android. What do I have to share then if the MVVM is all in native code? Well, you still have the domain and data layers, right? But let's look at the presentation layer first. So sharing the presentation layer is something that it is possible. It is challenging though, and you need a really great team to do that. If you do share the layer though, do prefer MVVM or MVI. The reason for that is that these don't really need to talk to the view, and the view will be using your MVVM or your view models or your intents, and so it makes it easier because you don't have dependencies from left to right. Otherwise, you need to write a lot of boilerplate to connect your views to your view models. Now, you don't really need a framework to write shared view modules or shared components, but they help. And there's a great talk coming up later today from Arkady on Decompose. So I recommend you going there and seeing that if you're interested in sharing your presentation code. As I mentioned, you really need an experienced team to share the presentation layer. And the reason for that is that whenever you have just Android developers writing the presentation layer that's going to be then shared by iOS developers, oftentimes you can get into a scenario where it won't be consumable by iOS developers because, again, you may use seal classes, for example. That makes it so much more difficult to share that. So, and also, if it's just iOS developers writing that, you will have the same issue on Android. So just keep that in mind. It's also something that those frameworks can help you with, where they usually provide a shared APIs that work for both platforms, Android and iOS. Just keep in mind that if you do use the framework, there's really usually not an easy escape route if you don't want to use it anymore, and it usually needs a lot of rewrite. The domain layer, on the other hand, is usually, again, I say perfectly shareable, but take that with a grain of salt. As long as you don't really expose any platform APIs, you should be able to share all of your domain logic. And the business logic, the domain logic, is the most important one to share. So if you don't want to share anything else, I do recommend going with the domain layer because you can make sure that all of your business logic, all of your rules are written just once. And also, it gives you more time to test it because you have, instead of writing tests twice, you just write them once for the shared domain layer. And the domain layer is usually like services, models, gateways, all of that encapsulates your business rules. And last but not least, the data layer. So again, usually shareable. It will really depend on your what technologies you use on your backend and how you communicate with your backend, and also how you want to store data. So if you're fine with storing data locally with SQLite or Realm, then you'll be fine. But if you do need something custom like core data or Room, then you may need to, you can create just interfaces in the data layer that's shared, and the rest is custom for each platform. I've mentioned some frameworks here, so SQLite and Realm for data storage, Cater Client and Apollo for communication with the servers. It's all you basically need in the data layer, and all of that is multi-platform, so you can just use it and start writing your shared code. As Pamela already mentioned, the multi-platform UI, that's one of the things that in Kotlin you don't really get today. There is the Compose iOS, as Greg mentioned in the keynote, but it's really not ready for production. Those of you who have iPhones, I don't know, any iPhones? A lot of iPhones, actually. So if you have the DroidCon app, how many of you have switched back from Compose UI to Swift UI? Not that many, surprisingly. Maybe you just didn't find the settings, so it's in settings, and it's way better user experience if you do switch it off. So you have the Compose for iOS. It's cool, but it's just not there. But in the future, try imagining, instead of replacing native UI altogether, just replacing things like settings or like something that users don't really interact with on a daily basis. That's where the multi-platform UI like Compose will play a great role, because you don't really need to be writing that twice. And last thing I want to mention, I know that everyone know what happened. Sorry about that. So last thing, everybody knows, use dependency injection, right? But I think it bears repeating, especially with KMM. And the reason why I'm saying that is, oftentimes in tutorials you see usages of the expect actual for KMM. So expect actual is great if you do need to have something for like iOS and Android, maybe desktop. But use it as minimal, like only use it where you really need that. Use it always try to use dependency injection first. Multiple reasons. Testing is easier if you use dependency injection because you can inject a different implementation, mock implementation, and so on, which you can do with expect actual. And the other one is it's just better for maintenance because, again, injecting lets you inject a wrapper, proxy, anything you want. Whereas with expect actual, you always have just one implementation per platform.
It looks like the ugly testing iguana came in for a visit. So in this section, we'll be talking about a few things related to testing on Kotlin Multiplatform Mobile. For the most part, I'm really going to ignore how tests on Android works because it's both as ugly as this iguana. Maybe you think it's beautiful, but it's really ugly. And as widely talked about and documented as it can be. There is a talk later, I think, about it as well. So if you're really interested about testing in Android, go to that talk. First, we'll talk about how we can test shared code in common main, and then also talk about expect actuals. And then we're going to very lightly take a little journey into iOS UI testing. So before we start diving in, it's a really good idea to look at the project structure first. Each source set in the shared module has a corresponding test source set that it depends on, that it matches. So Android main has Android test, common main has common test, and iOS main has iOS test. If I want to go ahead and test some shared code, I would basically first have to edit my shared build gradle.kts file, which is a Kotlin script extension. And I would have to add these dependencies to common test and also to Android test. Now, that might surprise you. Why do I have to add extra stuff to Android test when I'm just running it in common main? But the reason for that is that we need to run our tests on a particular platform. So we need to add these dependencies, otherwise we get a runtime error. And iOS doesn't need the additional dependencies because it's already part of the platform. So if I wanted to test some shared code, this is my example. So it comes from the onboarding documentation that you can find on the Kotlin Lang site. It's step number 3. And I just made it slightly easier to test. So it calculates the days until the new year. So instead of calculating it based on the system clock and system time zone, I am just passing it in. So it just makes it slightly easier to test. And then I go ahead and it must look like a very familiar kind of test. It has the @test and annotation and a assert equals to test our function days until. So in this case, we're just testing that there is 365 days until from January 1st this year to January 1st next year. If I wanted to go ahead and test expect actual mechanisms, I would, for example, use this example. So in common main, I have an expect class called platform, and this is very similar to if you create a new Kotlin Multiplatform Mobile app. There's already like this platform class that's part of the default like little example code that is added to it. So in that class also has an OS name as a property. In Android main, we just hard code, we actualize, I don't know if that's a real word, but I just made it up. We actualize platform and we assign Android to that OS name. But on iOS, we actually use, in iOS main, we actually use iOS classes, functions, and properties in order to determine the system name, which should be iOS. We can also go ahead and expect the platform test. We're now in common test looking at expect class, and that means that we're going to mandate that we have both the platform tests on each supported platform as well as a test called test iOS name or OS name on each platform. And that is pretty good because then it's going to be on both Android and iOS, and we're forcing it. So, for example, on Android, we would have our actualized class, actual platform test, and then we're annotating a test that's an actual test and we're just checking if the platform.os name is equal to Android, and similarly on iOS test, we're checking that iOS is ignoring the case. We're just checking that it is iOS. I'd like to also just mention a shout out to mock KMP. It's a multi-platform framework for creating mocks and fakes. And the way that it works is really quite simple. You just annotate variables or properties in your class with @mock or @fake. No debates today about mocks versus fakes, please. We have more than enough drama today. So first, we go ahead and annotate. Well, we first have to extend the test with mocks class, and then we override the setup mocks function by injecting the mocks. So each mock or fake, you just annotate with @mock and @fake. And then you use lazy initialization to initialize this controller with a small c variable, and you pass in the mocks and fakes into your constructor there. And that's the basics of testing on Kotlin multi-platform. I'd just like to quickly show you what iOS UI testing looks like. So for that, just a little taster. You basically use the UI testing bundle option on iOS's Xcode. And then you have this template code that you can use. So I want to highlight a few differences and similarities between iOS and Android so that you understand it a little bit better. But note that this is Swift code, so you're actually testing the Swift implementations. So first we are creating this application. Then we override the setup function just to make sure that whenever we reach a test case failure, we actually stop testing. There's no sense in really continuing. But something to note is that iOS actually works by convention. So you have to prefix your test cases with the test name in your function. Your function name has to start with test for it to recognize that this is actually a test function. Whereas on Android, you have to annotate with @test, right? Now, something that's similar on Android is the use of semantics, especially in Jetpack Compose. So usually semantics is used for accessibility, but they've found a sneaky way around translation issues by giving this accessibility identifier to, for example, a button. And on this screen that I would be fake testing is this button called Click Me Button. And I would assign accessibility identifier of Click Me Button to that button, and I would test that using that XCT assert that button exists on the screen. And on Jetpack Compose, you do something similar. There's also a UI test recorder that you can use, similar to the Espresso tester, that you can use, even if you have to just clean up the code a little bit, but that helps you with just getting the interactions right between UI tests, UI clicks and taps and stuff like that, interactions.
Now I want to show you how to debug crashes, and I'm not gonna go into debugging Android crashes, as this is an Android conference, and you probably know way more about that than me. And we're gonna look at the iOS crashes instead, because that's more interesting. So first things first, in Kotlin, so Android, we have throwable as the main kind of error type, and then we have recoverable and unrecoverable events. All come from throwable, and so we have like errors that are unrecoverable issues, and then exceptions that are recoverable. On iOS, however, is the exact opposite. Errors are recoverable, exceptions are non-recoverable. So on the left, you can see how recoverable errors look like in Swift and Objective-C. So in Swift, it's part of the signature as the throws, and Objective-C, it's a parameter. And on the right, unrecoverable, in Swift, it's a fatal error, and in Objective-C, it's the exception. So that's different from the Kotlin, and here you can see on the left two Kotlin functions that behave semantically the same when called from Kotlin. So they both throw illegal state exception. You can catch that. You can decide what to do with it. However, as you can see, they get translated into something else when passing the barrier to iOS native code. So what it looks like is if you don't include that at throws, you don't really get to catch the crash. And it will crash in production. So oftentimes, if your app is crashing, look first if it's supposed to be crashing, if that's not an expected exception that you should be catching instead. And in that case, make sure to add that at throws annotation. It will make sure that it gets propagated into iOS. Now let's say that it is a crash that you should be crashing, and you need to figure out like why is it happening. So first you need stack trace. Unfortunately, with Kotlin Multiplatform, as it is now, you don't get stack traces in production code. Instead, you get this really ugly, like abort stack trace. And what you need to do is you need to include one of the two crash chaos or an exception kit libraries. So make sure to include that so you get proper Kotlin exceptions in your Crashlytics. If you use Kermit for logging, you will get that configured for you, so that's a plus. But you really need one of those to get that stack trace. Before I continue, I want to mention the new memory model. For those of you who are using KMM, if you're not using it yet, switch to it as soon as possible. It makes semantics between Android and iOS closer together, so it makes what I'm going to describe next easier. So first, you want to reproduce the issue on iOS. It's kind of the basic approach. So you reproduce, if you don't have an iOS device, simulator should work. There are slight differences, but it's mostly the same. So try and reproduce it on iOS so you know what the steps are for that crash. We're not debugging it yet, we're just reproducing. Then write a test. I hope that all of you have test suits ready, so you can just go in, write the test, and make sure that the test is read before you continue. And then if you do, you can just fix it, right? You can go ahead and fix it because you have a test ready. If you can run the test on Android or just JVM, it will make it easier for your debugging. So just try that. If it doesn't, then you have the native code, and you can debug the test itself and just fix until it's green. If you don't have a test suite, which is most of my apps, then you can try and reproduce the same issue on Android. So just try to do the same steps on Android first. If it crashes too, it's an issue in the common code, and it makes it way easier for debugging. Because on Android, the tooling is still better, because it's just JVM. So all of the tooling, you can step through your program, you can run functions, you can do whatever you would do in just a standard Android application. Worst case scenario, you couldn't reproduce on Android because it's a platform-specific thing or something in the layer between going from Kotlin Multiplatform to iOS. We need to go and debug an Xcode. Get yourself strapped in, it's a bumpy ride. You need to install Xcode Kotlin first. It's a plugin that will allow you to debug, hopefully, in Xcode, your Kotlin code. Then what you want to do is add Kotlin code into your project, add breakpoints in the Kotlin code. That should still work. And if you're lucky, if you're really lucky, this will be what you'll see. It will stop at your breakpoints. You can step through, and you can use the FRV in the LDB command line to print values. Now, I mentioned if you're lucky. Sometimes it will stop at those breakpoints, like here in the suspend function, but you can't really use the FRV because you're inside a coroutine scope, and you don't get anything outside of that. If everything else fails, which unfortunately is still the case for many use cases, you need to do print lines. And unfortunately, the compile times for Kotlin native are currently kind of long. So my recommendation for you is go in your code base, add as many print lines as you can around the debugging site where you're trying to debug, and then compile. Oftentimes you'll be like, oh, I know this. I just need this one variable, this one property. Then you recompile, you wait, run it. Nope, it's not that property. I need more. And then you continue and continue on and on. So do all of it at once, and then just reset in Git. Now, I want you to leave with these 3 key points. So Kotlin multiplatform is powerful, but it's challenging. As Hadi mentioned, Gradle makes it also very challenging to work with it. And the other challenge is in debugging in native. And so any crashes in native will just give you some headaches if you can't get them reproduced on Android. There are no silver bullets, so KMM isn't for everyone and isn't for every use case. However, it is ready, so use it now. It's in beta, so as ready as it's gonna be.
Yeah.
And yeah.
Or when it goes to stable.
But yeah, it's great. We can recommend it for your next project or just adding to your current project to share your domain logic. Here's our slides, if you want to look at our slides, but more importantly, we have Pamela's blog post with our resources, which we use to get this presentation together. I'm gonna leave it here for a second, and we can go to questions.
Yes. We have about 4 minutes of questions.
Yeah, 4 minutes, so any questions?
Hi. Shall I speak first? Okay.
Yeah.
So you mentioned we should use a sealed class, right? Because it's messed up in iOS part. So what shall we do instead? Normal classes, object classes. What shall we do? Or could you explain based on an example?
Yeah. So sealed classes on iOS, they don't give you the sealed thing, so you can like switch on them and exhaustively. But do come to me after this talk. We have something that like helps with that. We are closing on like a closed alpha with TouchLab, and so we might be sharing that real soon.
Yeah, so you mentioned that Canon is coming to what Swift directly. You have
Because now it's Objective-C and then...
Right.
So the question was, we mentioned that KMM is coming to Swift or improving the Swift interop a little bit, and that's true. So both JetBrains and TouchLab are working on it, but it's still in the works. So watch the space. Was that your question? Or?
Yeah, but will it eventually like get rid of Objective-C and just work with Swift?
That is what we're hoping for.
Okay. Thank you.
Just in the back. Question in the back.
Apart from the views, are there any aspects of development that must be written natively? So, for example, accessing the Bluetooth or the camera or any specific...
Please speak up. I can.
Sorry. Apart from the UI presentation, are there any aspects of the app which must be written natively in order to... So, accessing the Bluetooth, because I know you mentioned you create bridges, but are there any aspects of development that have to be written natively? Because the technology isn't caught up yet in KMM.
So, basically, like any platform code you need is when you need to access the platform APIs. So, for example, if you want to talk with like Bluetooth devices, that's usually a platform thing. There are so basically like all libraries you're gonna use, they have the platform code in them. They just abstract it for the common main source set, so that you don't need to interact with the platform as much, and so you can still drop down and write some basic platform code in Kotlin in the like iOS main or the Android main, or additionally, what you can do is you can create an interface in the common main and then implement that interface in Objective-C or Swift and use dependency injection to inject that.
All right. One last question.
One last question?
Okay.
Yeah.
Yes. Is there an overhead caused by the extensive use of coroutines inside of the common Kotlin code on iOS at runtime or not?
We don't know. So there's like it should be the same as it's when because like Kotlin compiles into native on iOS, so it's like real native code running on the iOS, and so like any overhead would be in how the Kotlin is compiled into native, and that's being optimized like with every release. They're improving that so that it's better and better.
Thank you.
That's all our questions for today. Thank you for attending our talk. We have stickers, so if you want some cool Kotlin stickers, please come see Tadeas and myself.
Thank you.